Hello, this is Mr. Stansbury. I'm going to take you through the 1E notes on factors of natural numbers. All right. So, factors. First of all, factors are all numbers that divide evenly into a given number. Okay. So, for example, the factors of 10 are 1, 2, 5, and 10, because 1 times 10 is 10, and 2 times 5 is 10. All right. When we write a number as the product of factors, we call that factorized. Okay, so when we write this 1, 2, 5, and 10, that's factorized, the factorized version of 10. Okay, prime number. Prime number is a natural number that is greater than 1, which has exactly 2 factors. So, for example, 2 is 2 times 1. 3 is 3 times 1, 5 is 5 times 1, 7 is 7 times 1, 11 is 11 times 1, and there's no other factors of any of those numbers. Okay, a composite number is a natural number that has more than 2 factors. So 4 is 1 times 4, but it's also 2 times 2. And 6 is 1 times 6 and 2 times 3, and then so forth and so on. Okay? And if you'll remember, 1 is a special number. It's not considered prime or composite. It's just considered special. All right, so remember that one. Okay, let's get into some good stuff here. The fundamental theorem of arithmetic says that every composite number can be written as the product of prime factors. Okay, so for example, example number 9 from page 27, express 252 as the product of its prime factors. Okay, so really probably the easiest way to do this is just to make a factor tree. So I'm going to take 252, and I'm going to start coming up with factors of that. I can't think of really a whole lot of numbers that go into 252 except for that it's even, so I'm going to just cut it in half, and that gives me, what, 126? Okay. And then I can break 126 down. That's still got a factor of 2 in it. And that gives me, what, 63? And I'm just going to keep doing this until I get down so that I've got all prime numbers. So 63 is 3 times, what, 21? And 21 is 3 times 7. And that's it. At the end of all these branches here are all prime factors, or prime numbers. So I'm going to express this as the product of its prime factors by just multiplying these, well, not multiplying them all together, that would give me 252, but just writing these all as powers here. So that would be 2 squared times 3 squared times 7. So this is, if you'll remember from the last section, this is exponential form. All right, so there we go. That's the product of all of its prime factors. Okay, and let's look at one other example here. Example 10. Oh, sorry. Well, let's talk about this first. Highest common factor. The biggest factor that 2 or more numbers have in common is called the highest common factor. Okay, so we're going to find the highest common factor of 18 and 24. So again, probably the easiest way to do that is just break it down into its product of prime factors. So let's do that. 18, and we'll do 24 also. So 18 is 2 times 9, and 9 is 3 times 3. Right? And then 24 is 2 times 12, which is 2 times 6, which is 2 times 3. Okay? Now what we want to do is we want to figure out which factors these two numbers, prime factors, they have in common. So they both have a 2. Okay, and then they both have a 3. And you'll notice the only factor this has left is a 3, and the only one that this has left is 2's. So now all we need to do is just take these two prime factors and multiply them together. 2 times 3 is 6. So our highest common factor of 18 and 24 is just 6. Okay, and we can find it using our product of prime factors. All right, that's really all there is for this section. If you have any questions, please feel free to ask, and you should now be able to say that I can break any number into its prime factors, and I can find the highest common factor of 2 or more natural numbers. All right, thanks.